Today's talk comes with a health warning. It's a bit depressing. The title of this talk reflects the content, of course, and there's two concepts in here. We're talking about shorebirds, and we're talking about the disappearance of shorebirds across many of our shorelines across Australia. And we're working hard to try and understand why that might be going on, and perhaps more importantly, what we can do to reverse the situation. The work I'm going to talk about today is the work of a large number of people at the University of Queensland and other institutions. So there's at least these 10 people plus a number of others who've worked heavily on the work I'm going to present today. So this is by no means a single effort. So it's the work of a great team of people over at UQ. On the 17th of March 2007, a female bar-tailed godwit, a kind of shorebird, was banded with a satellite tag in North Island of New Zealand. That bird took off and 7 days later landed in the Chinese Yellow Sea on its migration northwards towards the Arctic. The bird undertook a 10,300 kilometre single flight without stopping, without landing, all the way to China from New Zealand. That's about as far as an Airbus A380 can fly. And these birds are a few hundred grams. Incredible feats of migration. That bird then stayed for several weeks in the Chinese Yellow Sea, up here, in the region between the Korean Peninsula and China, feeding on the invertebrates in the huge tidal flats present in that region. After it had refueled enough to carry on, it took off from the Yellow Sea again and flew right across the northern Pacific Ocean in another flight of 6,500 kilometres and touched down in Alaska on the huge tidal flats just outside Anchorage. The bird then went up onto the Arctic tundra, laid its eggs and bred. This was a female bar-tailed godwit. The researchers were pretty excited to have captured that northern migration of the bar-tailed godwit. It was the first time that that link between our part of the world and the Alaskan breeding populations had really been documented. But what happened next blew the socks off the researchers. They'd expected the battery on the satellite tag to have run out by now and for it not to capture the southward migration. And what happened next was the longest recorded flight ever of a single migrating bird. That bar-tailed godwit took off from a tidal flat near Anchorage on the 30th of August after having bred on the Arctic tundra. It then flew right across the Pacific Ocean on a single flight of just under 12,000 kilometres before landing back on the same tidal flat it took off from before in New Zealand. Just an unbelievable feat of migration. We can think about these things intellectually, but just think about the journey that this bird must have undertaken. It's just quite incredible, the feats which these birds go through. They shut down half their brain alternately instead of sleeping. It's pretty dangerous falling asleep while you're flying. It's not really a good idea. These birds have incredible physiological adaptations to coping with these enormous migrations. They lose half their body weight. They arrive completely exhausted, skin and bones almost. You can almost see the bones poking through the skin of these birds. They're so exhausted and emaciated when they finish their migrations. But they're so finely tuned. These godwits take off on pretty much the same day every single year. They typically leave on the 17th of March from New Zealand. And the same individual godwit has been shown to do that several years in a row. Leave on the same day. These birds are incredibly finely tuned to their strategy of migrating. So they're connecting about as far as you could possibly go and remain on land on the planet. These birds are using, half a hemisphere as their backyard every single year. Incredible feats of migration. And the migration route even spelt out a nice heart for the researchers. And they have this particular bird called E7. They're very fond of her. She doesn't migrate anymore. She's kind of retired and she is seeing out her days on a tidal flat in New Zealand. But E7 showed us the majesty and the wonder of this migration system. Fascinating stories. And that's just one individual bird amongst millions, somewhere between 4 and 8 million individual birds migrate between the Arctic and Australia and New Zealand every single year. These birds are taking advantage of enormous flushes of resources during the northern summer in the Arctic. Insect abundance, if you've ever been there, staying clear of mosquitoes is a pretty much continuous pastime in the Arctic. There's an enormous amount of insect food and availability for these birds to eat, and they're cashing in on that over a brief period in the Arctic. Then they're migrating all the way south, feeding on, often stopping along the way on tidal flats. Very few of them can do those 12,000 kilometre single flights. Most species and most individuals have to stop and refuel along the way. But essentially there's this busy superhighway of migrating birds that connects 16 countries across Asia, and connects the Arctic with us right here in subtropical Australia. Many of the shorebirds that you see if you go out to Moreton Bay, they're Arctic migrants. They're breeding in the Arctic and they're coming to Australia during the austral summer. These birds live in summer their whole lives. They go into the northern hemisphere for the northern summer and come down here for the southern summer. They're pretty smart migrants. You may have detected by now that I'm not Australian, I'm actually British, and I moved to Australia in 2008. And when I arrived in Australia, I was amazed by the number of people who love these shorebirds in Australia. It's one of the aspects of Australia's biodiversity that's captured the public imagination, I think, in ways that many other environmental issues haven't. There's thousands of people who form part of community groups across Australia who go out and monitor these birds on a regular basis. Thousands of people do it. We reckon about 2,000 people contributed the data, which I'm going to show you and present in this talk. That's a huge citizen science effort from across the continent. Australians love counting shorebirds. And the Queensland Way to Study Group, which is based right here in Brisbane, came to us a few years ago and said, can you help us analyse the data that we've been collecting over the years? Help us understand what's going on. We're a bit worried about some of the changes that we're seeing. Can you boffins at the university help us understand it and analyse these data? And the kinds of data sets are incredible that these volunteer counters have been collecting. To be honest, probably something that's way better than could be done through a formal scientific research program. These guys have been doing regular monthly counts every single month for 20 years now. That's very difficult to arrange that kind of long-term activity through standard scientific grant cycles and so on. So huge staying power and hugely high quality data. Many sites across Moreton Bay have been monitored every month for decades. So we began to analyse these data and take a look at what was happening with the shorebirds here in Moreton Bay. And it didn't take us long before we began to see why these citizen scientists were becoming so concerned. We assigned one of Australia's most hotshot statisticians to this problem, to analyse these data. They're noisy data, they're difficult to analyse. These birds are migrating to and from Australia. The patterns are noisy. The birds are coming and going. There's lots of error in the counts and so on. It's a very difficult kind of data set to work with. But you don't need to be a statistician to extract the key message from a graph like that. We can all see that plainly. If you went to Moreton Bay in the early 90s, you might see 1,500 to 2,000 red knots, just one of those species that migrates to the Arctic and back. If you were to go to Moreton Bay now, you'd be lucky to see a few hundred of those things. That's a kind of a 90% decline for that particular species in Moreton Bay. What's going on? What could be driving that? Is it widespread? And I'm afraid to say, many of the migratory shorebirds in Moreton Bay are declining very rapidly, or have declined very rapidly over the past 2 decades, right here on our doorstep in Brisbane. It's probably not an exaggeration to say the populations of many of these species are in free fall in Moreton Bay. These percentages that you can see here, they're not declines over a 20-year period. These are annual rates of decline for each of those species. Annual rates of decline. That is a pretty catastrophic change in population size for any. No species can cope with that. Losing 9% of your population every single year as the red knot has been doing for the last 2 decades in Moreton Bay. Now that, of course, was worrying, but a key insight came when we realised that the resident species that spend all year in Moreton Bay and Australia are not declining. Their populations are moving around, yes, but they're pretty stable over the long period. There's no decline in those resident species that spend their whole year here in Australia. That led us to think, could the cause of these declines for the migrating birds be situated outside Moreton Bay? Is it an issue within Moreton Bay, or is it a problem that's being driven from outside? The fact that the migratory species were declining suggested the latter. And think about it. I'm just going to show you kind of a cartoonified example of how migratory species might be more vulnerable to threats like habitat loss than resident species that stay in one place the whole year round. Imagine you have 3 patches of habitat. Imagine these are 3 patches of forest or something like that. If we lose part of one of those patches of habitat, we expect the overall population size to be affected only insofar as that piece of habitat has been lost. Now imagine that these patches are connected by migration and that all individuals in the population are going through each patch and back every single year. We might now expect to lose a quarter of the entire population here just because of this one fairly small area of overall habitat loss. So migratory species, theory suggests, are more vulnerable to habitat loss than resident species that stay put all year round. And there's been a bunch of theory that's shown that over the years. Just to give you a slightly more complicated example, it crucially depends on where habitat loss happens if you're a migrating species. In this example, we have, say, a breeding area that's up here and a non-breeding area down here, and then some stopover sites along the way on which the migrating individuals might stop and refuel. Imagine a case where we lose 2 of those important stopover sites. The consequences for the population depend crucially on which 2 sites you've lost, on where that habitat loss happened, not just how much. Okay, so another reason why migratory species are acutely vulnerable to habitat loss. And relatively small amounts of habitat loss can cause big effects on populations. And I'll show you some more evidence of that later. Okay, back to the story. So after that Moreton Bay work that we did here in Queensland, we teamed up with 14 organisations across Australia and New Zealand who'd been collecting count data, this citizen science count data, over many decades. The idea of this project was to try and work out whether these declines we're seeing in Moreton Bay are representative of everywhere across Australia and New Zealand. Is it just a localised problem to Moreton Bay, or is it a general problem across the whole continent? That's crucial for understanding what might be causing it. Queensland State Government were key partners in that ARC linkage project that saw most of this work happen. The federal government were also partners, and the Queensland Wader Study Group themselves, along with the Port of Brisbane. So, key partners who were keen to see the results of this work. And the first thing we did was to sit down with a bunch of shorebird experts and say, okay, what do we know about the migration routes of these birds? How do we interpret any changes that we might see here in Australia? So we sat down, and for about 10 or 12 species, we managed to get good maps in which the experts were fairly confident describe the sort of migration pattern that these birds undertake. Here's just one example, the eastern curlew, a species that should be familiar to most of us if you've spent any time looking out onto the tidal flats right here in Moreton Bay. Hugely, as shorebirds go, this is a charismatic species. Okay, it's brown, I admit, but it's pretty big and it's got a huge long beak. I think it's a pretty cool bird, and they make really cool noises. So this is the eastern curlew. This species breeds in the low Arctic up here, so it's not a real high Arctic specialist. But here's a key feature. All of the population, this is the entire global population of eastern curlews, stops in that yellow sea region to refuel on the way to Australia. All its eggs are in one basket. That's where that species refuels, basically nowhere else. And then after that refueling, the birds then fan out across Southeast Asia, but largely they're restricted to Australia during the austral summer. Queensland is actually the global headquarters for this species. It's quite rare now globally. So this is one migration strategy, just stop in the Yellow Sea, then carry on. And here's a much more complicated one. I'll just show you this second example. This is the curlew sandpiper. This species has a much more diversified sort of migration pattern. It can use many more different kinds of habitats. But in fact, if you work all of this through and study their northward and their southward migration, which are actually different routes, it's complicated. It's taken 30 years to work out this stuff. Actually, this species is also hugely dependent on the Yellow Sea as a stopover site. Basically, the whole population at some point or other goes through the Yellow Sea. So there's a clear pattern that this Yellow Sea region is crucially important, and we're going to come back to that in a few minutes. So what we did in this project was to look nationally across the continent of Australia and New Zealand. For the sake of simplicity, I've left New Zealand off this map. What we did was to assemble population trend and count data from lots of different sites around the country. This slide is just a small snapshot of some of those sites. And we can begin to see, are these trends consistent across the continent, or are there clear sort of spatial patterns in where and how fast these different species are declining in different places? So this is the kind of method we used, and a highly talented postdoc called Colin Studds pulled all of this stuff together and conducted statistical analysis to figure out, is there an overall trend, a national signal, or is stuff just going up in some places and down in others? And there was a very, very clear national trend. For many of the species we studied, for 7 of the 10, there was a significant national decline. Here's just a couple of these species that we're following through this talk. The curlew sandpiper on the top, I think is a really cool shorebird, but you might see that and go, well, it's a little grey-brown bird, but I think they're cute. The curlew sandpiper has declined dramatically. The stats from this are that the curlew sandpiper has declined by 84% in 3 generations. Now that is a catastrophically rapid decline. No population can withstand that. That is a fast trajectory towards extinction. And this is a species that was once fairly common. It actually still is quite common. It's just only 16% as common as it was 25 years ago. So these data are stretched across a nice, decent time series. They're quite long time series as data sets like this go in Australia. These are good data nationally. Eastern curlew also declining quickly nationally, and it's just going down and down and down and down and down. There's no kind of obvious break point. It's just a population that seems to be heading in one direction only. And if you put all of this stuff together and say, okay, of these key migratory shorebirds that we have visiting us here in Australia, which ones are in overall decline, as far as we can tell, across Australia and New Zealand? I'd like to say we have data from everywhere across their flyway. We don't. The only data we really have are from Australia and New Zealand. But it gives us a good idea of what might be going on across the entire flyway for these species. 7 of the 10 are declining significantly continent-wide. Curlew sandpiper leads the charge right here at this rapid decline rate of about 7% per year. We're now talking nationally for populations that have hundreds of thousands of individuals. Number of other species declining incredibly quickly. We could detect no clear spatial pattern in these declines. They seem to be just declining everywhere. Almost everywhere you look across the continent, these birds are in decline. But that began to suggest to us that the main driver of these declines may be located outside Australia, and we're just receiving fewer birds each year from the flyway. Everywhere across Australia is seeing lower populations. Unless there's some kind of threat that's so diffuse that it's in every shorebird site across the entire continent. So now we've got a problem. We can detect declines reasonably easily. We have quite good data. That doesn't really help us turn the situation around at all. The next question really is, why are these declines happening? If we want to manage this situation and help reverse them, we first need to know, why are these declines happening? And where do you look for these amazing global nomads that are travelling 20,000 kilometres every single year on their migrations? Where do you go looking to diagnose what might be causing these rapid declines? Do you look in the Arctic? Do you look in these stopover sites in Asia? Do we look in our own backyard right here in Australia? Where do we look, and what kinds of threats do we try and look at? It's in some ways a daunting challenge. And we've tried to look across various places across the flyway of these birds. And of course, coastal development and habitat change is happening right here in our backyard in Australia. Many people will recognise the reclamation at Port of Gladstone. In and of itself, a relatively small reclamation project. But of course, there are concerns about coastal development in Australia, and a key need to try and help make that development sustainable. But there are changes to coastal habitats happening right here. And perhaps some of those may be responsible, at least for localised declines. We don't really know. What we do know, which I think is fascinating, is that some of these declining shorebirds are actually doing quite well in an occasional site here and there. And that may be a crucial insight that might help us work out what we can do in Australia to manage this situation. I think the last thing we should do is hang our hands up and say it's someone else's problem. We can and should be managing here in Australia. This is the Great Knot. And the Great Knot is declining at 4% per year nationally. It's in big trouble. These data are from the Great Sandy Strait. Great Knots have been increasing there year on year in a relatively healthy population there in Great Sandy Strait. What's going on in Great Sandy Strait that's different to some of these other sites? Can we learn something about how that area is managed and apply that elsewhere in Australia? So my message is, there are things that we should be doing here in Australia. And we're now going to head overseas and have a look over there. Another threat that happens across the flyway for these birds, whether that's in Asia, East Asia, Southeast Asia, here in Australia, is disturbance. As well as development and habitat change, coastal environments are loved by people, and that's great. Coastal environments are heavily used by people for recreation, for commercial activities. I love camping on Fraser Island, it's brilliant. But we drive up and down the beaches when we go there and so on. There's a lot of use of coastal areas. And that causes, undoubtedly, some impact on migratory shorebirds. Imagine you've just dropped in after a 12,000 kilometre flight. And you're subject to disturbances and so on in your foraging habitats. Managing disturbance to our shorebirds is something we can do, and we know how to do it here in Australia. And we've been working with marine park managers in Moreton Bay to try and quantify the effects of managing for this kind of issue. We have some data both collected before and after enforcement officers have been out from marine parks, engaging with people, talking to them about shorebird disturbance on beaches. In particular, off-leash dogs are a particular problem. And marine park rangers are well trained in dealing with that issue. And we have some data that shows that that kind of work is effective. Up to a 20% decline in disturbance after marine park rangers have been out talking to people. Generally, it's a hearts and minds approach, talking to people, helping them understand the fact these birds are migrating and really need time and space to refuel and so on. So we can do stuff to help these shorebirds while they're here in Australia. But let's zip from Australia to the other side of the planet. Remember, these birds, when they go to the Arctic, they're almost like completely different species in a way. They become terrestrial birds. They feed on insects in marshy ground. They're building their nests in the Arctic tundra, and they're completely different birds. They take on these incredible summer plumages instead of the grey-brown non-breeding plumages that they have while they're here in Australia. What threats are happening in the Arctic which may help us explain some of the declines that we're seeing? Well, one of the obvious ones is climate change. The Arctic's climate is changing more rapidly than anywhere else on the planet, with rates of temperature increases about double that found elsewhere across the world. Perhaps rapid climate change is already exerting an influence on the migratory shorebirds that breed in such a high Arctic region. And of course, there's nowhere else to go. If you breed right at the northern end of the world's landmass and the climate warms, where else can you go? There's nowhere else to go. You're kind of squeezed out. This has happened before. 8,000 years ago, it happened in the mid-Holocene climate optimum. These Arctic breeding shorebirds constricted to small areas that were still climatically suitable. And we have a student who's trying to work out what does the immediate future look like under rapid climate change. Hannah Walkup has been modelling the Arctic, the distribution in the Arctic for these shorebirds that we're also seeing here in Australia. So this is the breeding distribution for the Pacific golden plover. The white dots show you places where it's been observed, and the shading shows you climatic suitability for that species to breed in the present day. So here are data from about 2010. If we then fast forward that under even a middle of the road climate change scenario for 2070, we see a rapid loss in climatically suitable breeding habitat for this species in the Arctic. In fact, much of the suitable habitat suddenly switches to the other side of the world. And that's actually a pattern we see for many of the Arctic breeding shorebirds. The key refugia for these species will be Arctic Canada, parts of Greenland, and some of the islands off northern Russia. And that's exactly what happened about 5,000 to 9,000 years ago. Those are the places where shorebirds were restricted to in the last warming period that the world saw. So we may well be seeing that unfolding again. But what happens when these birds are leaving the Arctic, of course? They're having to stop and refuel on these amazing, huge migrations that they undertake. They arrive exhausted and emaciated. They must refuel to continue their migration. They need high-quality habitat, and they need lots of it. Individual flocks of birds in the Yellow Sea can have up to 500,000 birds in them, like one flock of birds. It's just an unbelievable sight. And you suddenly realise there's 500,000 birds eating breakfast, lunch and dinner. You know, that's an awful lot of biomass that's being consumed. They need high quality habitat and lots of it. And here's a satellite image taken in 1975 of some of that beautiful habitat in the Yellow Sea region, this area between the Korean Peninsula and the northeastern Chinese coast. You can see a coastline that is, yes, it's developed, but there's also a broad, fringing tidal flat that covers much of this area. In fact, this Yellow Sea region is one of the areas of the greatest tidal flats in the world, or at least it was. Here's another satellite image that was taken of that same place in 2010, just 35 years later. Now we see a coastline that is not just developed, but fundamentally transformed. If you look on Google Earth and just scan around the coastlines in this part of the world, most of it's straight. Most of it is sea walls that have been built, reclamation projects, large bunds in which there's now aquacultural development and so on. Just check this area out on this side here. So, you know, a huge reclamation project has gone in there and converted a very large area. Almost no tidal flats left in that particular region. Of course, we can cherry pick individual examples like this. And you may well be sceptical and say, well, you've just picked the worst place. But unfortunately, that's not the case. A highly talented PhD student called Nick Murray spent 2 years battling with satellite data. It's hard data to work with. And it's very hard when the tide keeps going in and out and covering up the thing that you want to measure. He spent 2 years trying to map tidal flats using Landsat remote sensing data. Again, I'm afraid I gave you a health warning at the beginning. You know, the results are pretty depressing. About 2/3 of the tidal flat habitat in this key stopover site has been lost in 50 years. It's gone from 1.6 million hectares that we could measure down to 600,000 hectares, two-thirds loss of staging habitat for for these birds. Now that is a threat of the kind of magnitude and the kind of timing that could be driving the declines we're seeing here in Australia. And many people had realised this before, that the yellow sea may be why our species are declining. No one before had mapped the extent and shown how dramatic and widespread this habitat loss actually is. But why is it happening? Is it these flagship reclamation projects that are causing most of this habitat loss? Actually, no. If you look right now at many of these places where the tidal flats have disappeared, the tide goes out and you just see ocean. There's no reclamation project, there's no hotel, there's no car park. The tide goes out and the flat's gone. We think the main reason for this is a massive reduction in sediment loads of the big East Asian rivers that are dropping sediment into the Yellow Sea. There's been a 90% decline in sediment loads carried by the Yellow River in 50 years. Damming and reduced flows of many of the big rivers have really reduced the amount of sediment coming out. So we think that erosion is now simply outpacing supply of new sediment. And many of these tidal flats are just disappearing because of that. And the reason that's important is, of course, because the kind of management needed to deal with that issue is not coastal management, it's catchment management. And it represents an intimate link between catchments and coasts that needs to be thought about in regional planning. But the other half of this pie chart, the other half of the equation is rapid coastal development. There's no question about that. Reclamation of land, or I don't like the term reclamation, but I can't think of another one that properly describes it. Appropriation of tidal flat, maybe. Into agriculture, aquaculture, and urban and industrial development. And we've just published this work in an open access paper in Frontiers in the Ecology and the Environment. So you can download these and check out the maps. So there's a big problem that requires an equal measure, if you like, coastal planning and catchment planning. Those things have to happen hand in hand to solve this problem. And of course, it's a tough challenge, of course. If you're a city mayor, you have a choice between trillion-dollar hotel complexes or smelly tidal flats that have lots of brown birds on them. I know what I would choose. This is a difficult economic, environmental problem. It's by no means simple. It's a wicked problem, I think, in all senses of the term, and it's going to need fundamental and huge changes to reverse this situation or arrest it from getting worse. And here's the rub. If you look across these shorebirds across Australia, we have good data for 10 different shorebird taxa across the Australian continent. Good data on their rates of decline. We find that the species declining most quickly here in Australia are those that are dependent on the Yellow Sea for their stopover sites on migration. Towards the right of this plot, so the x-axis here is the proportion of each species' stopover sites that are in the Yellow Sea. Okay, so if you're up the right-hand end, 60 or 70% of your stopover sites are in the Yellow Sea. You're very dependent on the Yellow Sea when you're on migration. Those species have declined or are declining the most quickly in Australia. On the other side of the coin, those species that largely avoid the Yellow Sea on migration are actually doing fine. They're either not declining, some of them are even increasing nationally across Australia. In fact, we can explain 90% of the variation in population trends for these species just by knowing how dependent they are on the Yellow Sea. To us, that is quite strong evidence that the Yellow Sea is the main driver of these declines. We think the picture is becoming clearer. And on top of this, sea levels are beginning to rise perceptibly in the Yellow Sea, measurably, and the rate of sea level rise is expected to increase over time, over the next few decades. We've also been looking at what some of the future impacts might be if one's planning for the long term to try and reverse this kind of situation We've got to get that planning right and do it effectively. So we've been looking at how sea level rise might impact habitats across the migration routes of each of the species in our sort of study system. We've thought about each sort of node, each set of sites, and how will that be affected by sea level rise? How much habitat might we expect to lose as a result of sea level rise? Making various different assumptions about coastal squeeze and so on. What will the consequences be? And here's the answer in a nutshell. On the x-axis here is the sea level rise scenario, if you like, going from no sea level rise up to 3 metres, which is almost certainly an over-exaggeration. This covers the whole range of sea level rise scenarios we might expect to see in the next 100 years. And the black line shows you how much habitat overall we expect to lose as a result of that sea level rise. Literally, how much tidal flat and intertidal areas might we lose as a result of that? The red line shows you how much population loss we might expect as a result of that habitat loss. Think back to that cartoon I showed you at the beginning. These migrating species, they need every site to be intact. And actually, the distribution of habitat loss is going to magnify the impact of that loss because these species are migrating. And we can use techniques in conservation prioritisation to figure out where we should act across a migratory flyway that's connected by individual animals moving around this flyway. Where should we invest, in this particular example, for protecting a habitat against sea level rise? Where do we invest to allow coastal retreat to happen, to allow protection of upshore habitats and so on? Where do we invest under that kind of scenario? We have methods for doing this across broad scales. And this may seem like a hopelessly ambitious kind of plan, but there are large groups of countries collaborating across this flyway to try and solve this problem. This sort of stuff is doable if we can have the science catch up with the problem, if you like. So what do we do about this? I hope you're all feeling thoroughly depressed. And I think it is depressing. And I think, unfortunately, that's the first part of the journey that we're going on. I think we got to expose the nature of this problem, trying to understand why it's happening before we can really figure out what to do. That said, there is a huge amount of activity already happening around this flyway, and we're delighted to be part of it. First thing that's happening right now is that the federal government has nominated the eastern curlew and the curlew sandpiper for threatened species listing under the EPBC Act. These species are already listed because they're migrants, but recognising their status as threatened definitely helps raise their profile within Australia and properly recognises the big declines that we're seeing in these species. The curlew sandpiper has been nominated as critically endangered. That's incredible. This isn't a parrot where there's about 20 of them left. This is quite a common species that's found around the large part of the Australian coastline. So that's beginning to happen. Recognition of this problem is beginning to happen, and that can only help galvanise more action. We crucially need to protect the remaining sites for these migrating birds before it's too late for them. And the East Asian Australasian Flyway Partnership has protected 100 sites across the flyway through agreements between countries. A huge amount of progress is being made in protecting these sites. Collaboration is happening. I think we need to think about restoring some of these lost tidal flats. In one development in Korea, reclamation development, an area about the size of Moreton Bay was reclaimed in a single reclamation project. Now that is a huge amount of engineering prowess required to do that. Now if we have that kind of engineering prowess, I'm sure we can divert some of that energy to restoring tidal flats in places where they've been lost. It can be done. There are 2 flagship projects in Australia where tidal flats have been restored and shorebirds have begun to use them again. In Botany Bay, in Sydney Olympic Park. It can be done. Those are a few hectares. We need a few thousand, a few 100,000 hectares. So we need to step up our game. The Australian government is actively thinking about this right now. We need to improve catchment management. I hope I've convinced you this is not just a coastal management issue that's in that coastal box over there. This is an issue that needs attention from all across management portfolios, terrestrial, marine, and coastal, the little bit in between. We urgently need to reduce hunting. Hunting is, I haven't talked about it today, but it's a big issue, and we're beginning to realise how widespread and how serious an issue hunting is for these birds across the flyway. We need to work on managing disturbance, and of course, right here in Moreton Bay and across Australia, managers are actively working to try and manage disturbance, and we need to keep doing that and improve how we do it. And of course, really something that ties all of this together is that we really need to keep improving international coordination. It's difficult in this flyway. Not every country has signed up to the relevant international agreements across this flyway. It's a difficult situation to manage, but there are partnerships, informal at least, across all countries in this flyway. And that's a great vehicle for getting people talking and hoping to turn some of this concern into action. So yes, it's a depressing story, but there are things beginning to happen, and we need to turn what somebody called a glimmer of hope at a talk I gave the other day into a raging fire. We can make this happen. It's just that there needs to be a big vision, and it's got to be coordinated across a large number of countries to save these birds. What do we do here in Queensland as a result of some of this dramatic loss and decline that we're seeing? Now, my message is that yes, I think Asian habitat loss probably is the key driver of the declines of these birds. But that doesn't let us off the hook, I don't think. First of all, it means that here in Queensland and across Australia, we need to be working with other people across the flyway. There are partnerships, there's twinning projects between wetlands in Japan and wetlands right here in Brisbane. What a great idea for sharing knowledge across the flyway. School children are, talking to each other in different parts of the flyway, waving goodbye to the birds down here, saying hello to them in China and Korea. These things can help build international partnerships at all kinds of levels. It's not just a federal government responsibility. This is something that anyone can do, from a community group through councils and state governments and so on. Thinking about the international aspect of these migrating birds that are here for a part of the year. I think it'd be really cool to find out why some sites, particularly in Queensland, seem to be doing better than the national average. Why are they bucking the trend? And can we learn anything from that about management actions that we should be taking right here in Queensland? And I've been talking to Mike quite a bit about this. How do we raise the profile of this issue? I think we have some amazing stories here about what these birds can do, what feats they can do. And there's often this feeling amongst people that work on migratory shorebirds, this is so amazing, why doesn't everybody care about this? So I think communication programs that really help to celebrate the amazing biology of these species may help raise awareness and help solve some of the issues. So to sum everything up, our flyway is in big trouble. We have to wake up and recognise this. I think that Asian habitat loss is likely to be the most important driver of these declines. I think we have reasonably good evidence, possibly as good as we'll get, that that's the main driver. But that's not an excuse for inaction. We must act both here and across this flyway to save these birds. So let's act before it's too late. Thank you.